Hello everyone, in this video we are going to be solving an exact differential equation. First, we need to check if this equation is exact or not. This is our big F, this is big G, there is ds here. The trick is to differentiate this F with respect to y. So that will be partial F, partial y equal to, differentiating this function with respect to y, we simply have 4xy. That is, by considering x as a constant, comma, also here, we have dy. The trick is to differentiate g with respect to x. So that will be partial g, partial x equal to, differentiating this function with respect to x, we have 4xy. You will observe that we have the same value for partial f, partial y, and partial g, partial s. This means that the equation is exact. It is exact. As a result of this, there exists a function g such that partial g partial x is equal to big F. What is big F? That is 3x squared plus 2xy squared. 3x squared plus 2xy squared. And also, partial g partial y is equal to big G, 2x squared y. 2x squared y. We can pick either of the two and integrate. Let us pick this one. When we integrate this left hand side, we simply have g equal to integral of this 3x squared plus 2xy squared with respect to x. So g is equal to, integrating 3x squared with respect to x, that is s cubed, plus integrating 2xy squared with respect to x, that is s squared y squared, plus arbitrary function h. Let's call this star. The next thing is to differentiate this function with respect to y. So that will be partial g partial y equal to, differentiating s cubed with respect to y, that is 0. Differentiate this guy with respect to y, we have 2s squared y, plus differentiate h with respect to y, that is partial h partial y. This means that, what is partial g partial y? That is exactly 2s squared y. So we have 2s squared y equal to 2s squared y plus partial h partial y. This in turn gives 2s squared y cancel 2s squared y. We are left with partial h partial y equal to 0. Now, let us integrate this with respect to y. So we have h equal to, integrating 0, we have a constant c from equation star, which is this, g equal to s cubed plus s squared y squared, plus, instead of writing h, we just replace it with this constant that we have, h equals to c. So this becomes c. But that's not the required solution. If we set g to be equals to 0, this becomes s cubed plus s squared y squared equal to, transferring this c to the left hand side, we have minus c, which is also an arbitrary constant. So let's just write c, which is an arbitrary constant. Now, don't forget the condition we are given, this initial condition, where y of 2 equals to minus 3. So let us consider that. At y of 2 equal to minus 3. This means that x is equal to 2 and y is equal to negative 3. Plugging these values here, we have 2 to the power of 3 plus 2 squared times y is minus 3 all squared equal to c. What is 2 raised by 3? That is 8, plus 2 squared is 4 into minus 3 all squared, that is 9, equal to c. 4 times 9, that is 36. 36 plus 8, we have 44. So our c is equal to 44. This is the value of the constant. Therefore, back to this line, we now replace this c with 44. So we have x cubed plus x squared y squared is equal to 44. Let's write y in terms of x. This means that x squared y squared is equal to 44 minus x cubed. Divide both sides by x squared. We have y squared equal to 44 minus x cubed over x squared. If we take a square root of both sides, we simply have y equal to plus or minus square root of 44 minus x cubed over square root of x squared. Y equal to plus or minus square root of 44 minus x cubed over this bigger square root takes care of this power. We have x. Notice that this notation plus or minus means y has to be equal to square root of 44 minus x cubed over x, or y equal to minus square root of 44 minus x cubed over x. But there is another way to handle this. Let us test using our initial condition, which is y of 2 equal to minus 3. Don't forget our x is just 2. So plug in this value of x into this right hand side. Let's see what we are going to have. We are going to have y equal to plus or minus square root of 44 minus. If you plug this 2 here, that will be 2 raised to the power 3, which is 8, divided by 2. Y equal to plus or minus, this is square root of 36 divided by 2. Y equal to plus or minus square root of 36, that is 6 divided by 2. So y equal to plus or minus 3. It is obvious there is 2 solutions for y here, plus or minus 3. Now, if we carefully consider the initial condition that we have, y is equals to minus 3. That means, therefore, the required solution has to be y equal to minus square root of 44 minus x cubed over x. This is the required solution. That's it.